Those oval cutouts in hospital bed rails are not decorative. They are grip points engineered to a specific handspan measurement so a nurse can reposition a 200-pound unconscious patient with one hand while holding an IV line with the other. In the next 9 minutes, you'll learn exactly why those holes are shaped that way, how the 1970s nursing injury crisis forced their invention, what happens when designers get them wrong, and where the same grip logic shows up in completely unrelated objects. Most people assume hospital beds are basically just regular beds with wheels and some safety rails bolted on. That assumption makes sense from the outside. You look at a hospital bed and the rails seem like they exist to stop a confused patient from rolling onto the floor at 3 a.m., and they do serve that purpose. But the rail is also a tool, a working surface. It gets gripped, pushed, pulled, and torqued hundreds of times per shift by people who are already carrying something else, already leaning at an awkward angle, already tired. The rail has to perform under all of those conditions simultaneously. The oval cutouts are the engineering solution to that list of demands. And the story of why they landed on that specific oval shape goes back to a very specific crisis in American hospitals. In the late 1960s and into the 1970s, nursing staff injury rates in the United States were rising sharply. The specific culprit was patient handling. Moving, turning, and repositioning bedridden patients is physically brutal work. The loads are unpredictable. A sedated patient doesn't help you. Dead weight shifts, and the narrow frame of a standard hospital bed forced nurses into bent-over, twisted postures that loaded the lumbar spine at exactly the worst angle. By the mid-1970s, back injuries were the leading cause of lost work time among hospital staff in multiple states. The industry had a problem, and the equipment manufacturers had to respond. Hill-Rom, which was already the dominant hospital bed manufacturer at the time, began working with ergonomics consultants and occupational therapists to redesign the rail. The goal was to give nurses a mechanical advantage, something they could grab in a power grip, close to the patient's center of mass, that would let them pull lateral weight without twisting their own spine. The oval cutout emerged from that process. The oval, specifically, not a round hole, not a rectangular slot, an oval oriented horizontally, roughly 110 to 120 millimeters wide and 50 to 60 millimeters tall. That size fits the average adult hand wrapped in a power grip without the rail edge cutting into the palm. Round holes concentrate pressure on a smaller arc of contact. Rectangular slots have sharp corners that dig in during sustained grip. The oval distributes load across the entire palm and eliminates the pinch points. Now here's where it gets interesting, because not every country arrived at the same solution. In Scandinavia, particularly in Swedish hospital design through the 1980s, the preference was for full-length grab rails mounted on the wall beside the bed rather than integrated into the bed frame itself. The logic there was that a wall rail is always in the same place regardless of how the bed is positioned, so staff don't have to hunt for a grip. The Swedish approach optimized for consistency. The American approach optimized for portability, because the bed moves and the rail moves with it. You can wheel a Hill-Rom bed into an isolation room, flip it into Trendelenburg position, and the grip points are still exactly where your hands expect them to be. The oval cutouts in the side rail are essentially handles that travel with the patient. That portability was not a small thing in the era of rising infection control requirements, when getting a patient into and out of a negative pressure room quickly became a life or death variable. The deeper engineering insight behind the oval is something called affordance. Psychologist James Gibson coined the term in 1966 to describe properties of an object that communicate how it should be used without any instruction. A well-designed door handle affords pulling. A flat plate affords pushing. The oval cutout in a bed rail affords gripping. And crucially, it affords gripping at the right location, in the right orientation, with the right amount of force. Modern hospital beds from Hill-Rom, Stryker, and Linnet All place the primary grip cutouts at a height of roughly 600 to 700 millimeters above the floor when the rail is in the raised position. That is elbow height for a person of average stature standing beside the bed. Elbow height is important because it is the zone where a human arm can generate maximum pulling force with minimal spinal load. The oval is not just shaped correctly, it is positioned correctly. The shape and the placement work together as a single ergonomic system. Now, when does this system break? In 2006, a product recall was issued for a third-party bed rail accessory that had modified the oval cutout geometry to accommodate an integrated side table bracket. The cutout was elongated horizontally to about 160 millimeters. That sounds like a minor change. It was not minor. The wider opening meant that during a lateral repositioning pull, a nurse's hand could slide through the opening rather than being arrested by the rail edge. 3 reported wrist injuries in 6 months. The FDA classified it as a Class 2 recall. The manufacturer had optimized for the side table integration and inadvertently broken the grip arrest function that made the oval work in the first place. This is a recurring failure mode in medical device iteration. A designer solves one problem and unknowingly disables a safety feature that was never explicitly documented as a safety feature. The oval's width limit was never written down as a constraint. It was baked into the original ergonomic research and then assumed. When someone new came along, they had no idea they were erasing it. The same grip logic shows up in other places. The handholds molded into the underside of a kitchen mixer bowl. The oval depressions stamped into the grab handles of a transit bus pole. The recessed finger grips on a car's interior door pull. All of these are variations on the same principle. Shape a void to match the human hand in a power grip, oriented at elbow height, and eliminate sharp edges. The hospital bed rail did it first under the most demanding conditions possible, and the rest of product design borrowed the lesson quietly and without attribution. The oval in a hospital bed rail is a compressed record of a nursing injury crisis, a decade of ergonomics research, and a specific decision about what matters more: consistency of location or portability of grip. Every time a nurse hauls a patient back from the edge of a bed at 4 a.m. without throwing out her back, that oval is doing its job. If this is your kind of thing, the why behind the everyday object theory drops new ones Monday, Wednesday, and Friday.